Hey guys, welcome to another video for pre-calculus. We're still on 10.5, the binomial theorem. In this section, in this video, we're going to be working problems where we're expressing a particular expression, a binomial expression, and changing it into sigma notation. All right, so let's go ahead and dive in. Alright guys, so 10.5 binomial theorem, I'm going to be working out problems 39 and 40. So let's go ahead and dive into that. So problem 39 is 2q plus 3 raised to the 15th power. And so we're applying binomial theorem. So the general form for binomial theorem is a plus b raised to the n power, right? So these terms are all going to be important because we are changing this expansion formula into sigma notation. So with sigma notation, my n goes at the top, my r equals wherever I'm starting at, my r equals will go there, and then my n choose r, right? And then my a term with my n minus r times my b term raised to the r power. So that's what my general formula is going to look like. So that way I can kind of keep track of what I'm looking for and what I need. So what do I have? I have my A, I have my B. Let's see here. So let me write those off to the side here so we can see that. So I have my A term that equals 2q and my B term that equals 3. So I can actually go ahead and write out my A term. Oops, let me back up. So let's see here. My A term will go in here, which is 2q, and it's going to be raised to some power, times my B term, which is 3, and it's going to be raised to my r. Okay? So, all right, let's go ahead and get started. Actually, you know what? Let me rewrite that in black here. So I know it's going to be my n choose r, right? Well, what's my n? Do I know what my n is? It's 15. Do I know what my r is? I don't. I don't know what my r is, so I'm just going to leave it in its general term there. And actually, since I know my n, I know that my upper bound is going to be 15. And since I don't know my r, it's going to be 0. Now, recall that, this is in sigma notation, so I'm setting up the equation to work out any r that I want, any term that I want. So in the meantime, I'm just going to leave my r term, my r variable as it is. So I can replace it with whatever term I'm looking for later on. So my A term is 2q raised to the n minus r. Okay, so again, I know what my n is, so that's 15, so I can replace that with 15. And I'm leaving my r as it was. Again, going back to what I said earlier, I'm setting it up so that I can find any term that I want, and since I don't know which term I want right now, I can just leave r by itself. And then I'm multiplying it by b, and my b term is 3 raised to the r power. And that's it, actually. That's it. This is changing this expansion formula. Where is it? Right here. I'm going to highlight it in yellow. And then here is its sigma notation form. Okay? So let's work out another one so you can see this at work again. So how about number 40? So number 40, I have m minus 8n raised to the 25 power, right? So my A term is m, my B term is negative 8n, my n is 25, and my r, well, I don't know what my r is, so I can leave it as is. So I'm going to change this into sigma notation. So let me write out the general form of the sigma notation. So you know, I could always have it as reference. So it's going to be n choose r times my A term. Oops, let me back up. My A term raised to the n minus r times my B term raised to the r power. Okay, so let's go ahead and dive in now. So here again is my sigma notation. And my n is 25, my upper bound. My lower bound is 0 because I don't know yet. I can choose any any lower bound I want, so I'll leave it as 0 for now. And then my coefficient there, my n choose r, is 25 choose r. I'm leaving all my r's as is. And then my a term is m raised to the n minus r, so it's going to be 25 minus r times my b term, which is negative 8n raised to the r power. And that does it. This is the sigma notation to this expansion binomial term. Okay, so I hope this helped just in seeing how you can convert one from the other and how these terms relate to each other. So thanks for watching and good luck in your studying.